Hey, today I'm gonna review the antiderivative integrals. Today evening, I'm gonna review area and the volume. This is like the first part. I'm gonna review for antiderivatives and integrals. You need to memorize table of antiderivatives formulas. Assume that capital F of x is little f of x. Capital G prime of x equals little g of x. The k is a constant. We have this function k times little f of x. The antiderivative is the k times capital F of x. F of x plus minus g of x. Antiderivative is capital F of x plus minus g of x. The antiderivative of k is kx. The antiderivative x to the n is x to the n plus 1 over n plus 1. Antiderivative of sine of x is negative cosine of x. The antiderivative of cosine of x is the positive sine of x. Antiderivative secant square of x is tangent x. The antiderivative of cosecant square of x is negative cotangent of x. The antiderivative secant x times tangent x is secant x. The antiderivative of cosecant times cotangent is negative cosecant of x. So an antiderivative of f prime is f of x. The antiderivative of second derivative is the first derivative. The s of t is like a position function. So v of t is velocity. The a of t is acceleration. Just like v of t, exactly s prime of t. So n a of t is v prime of t. So this is like a second derivative of s of t. An antiderivative of acceleration is velocity. The antiderivative of velocity is position. This is one example. Find f. F prime of x equals secant square of x plus x squared plus 3x minus 2 over square root of x. F of 0 equals 5. So f prime of x is this one. You have to split it, right? So this part is exactly same to x squared plus 3x the minus 2 over x to the 1 over 2. You can split. The first one here, the second one here, the last one here. You can split. Next, simplify. Secant square of x, the power 2 minus 1 over 2 is 3 over 2. This is power 1. 1 minus 1 over 2 is 1 over 2. 2 times change to the negative exponent, x to the negative 1/2. Next, find f of x. The antiderivative of secant square of x is tangent. Plus, the antiderivative x to 3 over 2 is 1 over the 3 over 2 plus 1, x to the 3 over 2 plus 1. Plus the 3 times 1 over the antiderivative of x to 1/2 is the 1 over 2 plus 1, x to the 1 over 2 plus 1, minus 2 times 1 over the antiderivative of x minus 1/2 is negative 1 over 2 plus 1, x to the minus 1 over 2 plus 1. And simplify. The one more. Plus what? Constant c. This is 10x. Plus, what is this one? So we have the 5 over 2, the flip, 2 over 5. So 3 times, same. The 1 over 3 over 2, flip, 2/3. X to the 3 over 2. Minus 2 times the minus 1 over 2 plus 1 is 1 over 2, flip 2. x to the 1 over 2 plus c. The 3 is crossed out, so we have the tangent x plus 2 over 5, x to the 5 over 2 minus 4 times x to the 1 over 2. Sorry. So this one, you have to write second one, third one. The third one is here. The plus the 2 times x to the 3 over 2 minus 4 times x to the 1 over 2 plus c. This is exactly f of x. You can change it back to radical form. X to the 5 over 2 is the square root of x to the 5. X to the 3 over 2 is square root of x cubed. X to the 1/2 is root x. So next, you can use f of 0 equals to 5. You can plug the 0 into here. Plug into x. This one is tangent of 0. The 0 to the 5, 0. 0 cube is 0. The root 0 is 0. Equal to c. Plus c, sorry. Plus c equal to 5. Tangent of 0 is also 0. C is 5. Only plug 5 into here. So we have this answer. So like this. Tangent of x plus 2 over 5 square root of x to the 5 minus 2 times square root of x cubed negative 4x plus 5. The next problem, a particle moves in a straight line and has acceleration given by the a of t equals 60 plus 4. So this is like a typo. This one is its. ITS. Sorry about that. This is ITS. The its initial velocity is v of 0, negative 3 centimeters per second. Its initial displacement is s of 0, 5 centimeters. Find its position function s of t. So how can you find? You can find v of t first. The v of t is the antiderivative of acceleration. 6 times antiderivative of t is t squared over 2 plus 4t plus c. So we have 2 is crossed out. The 3t squared plus 4t plus c. Next, plug 0 into here. You can find v of 0 equals negative 3. You can use it. Much like a v of 0, 0 into here. So what happens? 3 times 0 squared is 0. So 4 times 0 is 0. Only remaining part is c. c equals negative 3. So you have to plug the negative 3 into here. The v of t is 3t squared plus 4 times t minus 3. This is the first one. Next, you need to find position s of t by using antiderivative. Keep 3. The antiderivative of t squared is t cubed over 3 plus 4 times antiderivative of t is t squared over 2 negative 3t plus another constant d. Let's simplify. 3 is crossed out, 2 is crossed out. So we have t cubed plus 2 times t squared negative 3t plus d. You can use the initial position s of 0 equals to 5 centimeters. S of 0 equals 5. You can plug 0 into here. The 0 cube, 0. 0 square, 0. There are 3 times 0, 0. only b equals 5. You can plug b equals 5 into here. We have final answer. The final answer is S of t equals tq plus 2 times t squared negative 3 times t plus 5. This is the final answer of this question. Like whole idea. This one. The next tip. The graph of function f is given. Make a rough sketch of the antiderivative capital F, given that capital F of 0 equals 2. So we know capital F prime of x is little f of x. The use increasing, decreasing test, concavity test, and first derivative. So what's like this meaning? What's like increasing, decreasing test? Increasing, decreasing test is this one. F prime is positive. The function f is increasing. F prime is less than 0. F is decreasing. What's like a concavity test? We can do second derivative. Another one is like this. So we have f prime is increasing. F prime is increasing. The function f is concave up. The f prime is decreasing. F is concave down. This is like whole idea. From 0 to 1, what happens? The graph is the below x-axis like -1. What does it mean? Graph is decreasing. So what happens at prime? F is like increasing here. F is increasing, F prime is increasing, F is concave up. So we have concave up. X is between 1 and 2. So 1 and 2. So here, 1 and 2 is positive above x-axis. Graph is increasing. One more. This is increasing graph, concave up. So 2 to 3. X is 2 to 3. So 2 to 3. So always positive. Graph is increasing. Another one. Graph is decreasing. The decreasing, concave down. X is 3 to 4. This one is below x-axis, negative. Graph is decreasing. So f of little f of x is like a decreasing one. Capital F is concave down. The 4 to x is greater than 4. What's that? Here. Below x-axis, graph is decreasing. So what happens at little f? Little f is increasing. So little f is increasing. Capital F is concave up. So we have these ideas. They're like this. This one. So you can just sketch the graph. What's it like a graph? Graph is like this. Here, 1, 2, 3, 4, and so on. What's like a starting point? F0 equals 2. So we have 2 here. The first one, with x in 0, decreasing, concave up. Graph is what? Decreasing, concave up. Decreasing, concave up. Like this. The 1 to 2, increasing, concave up. Graph is what? Increasing, concave up. Increasing, concave up. At 2, we have local minimum at 1. The 2 to 3, increasing, concave down. 2 to 3, concave change, concave down and increasing. So like this. The 3 to 4, decreasing, concave down. We have decreasing, concave down. So local maximum. The last one, 4 to infinity, decreasing, concave up. Here we have decreasing, concave up. Decreasing, concave up. So like this one. We have like this. Right? The next one. Integral a to b f of x dx. So we can use like limit and summation form. The limit as n approaches infinity, summation from any the I equal to 1 to n, f of xi star times delta x. So we have a choice of sample point xi star. You choose xi, right-hand point, the xi minus 1, left-hand point. Sometimes you choose midpoint xi minus 1 plus xi over 2. So what's that? So we have name, this xi is what? Right-hand point. So xi minus 1 is the left end point. This one is midpoint. We have this one. What's like delta x? Always p minus a of n. What's xi? The a plus I times delta x. Xi is right-hand point. Xi minus 1, left-hand point. Xi minus 1 plus Xi over 2 is midpoint. As a Riemann sum, on the ignore limit, summation from I equal to 1 to n, f of xi star delta x. So another one, what is area of R1 is A1, area of R2 is A2, area of R3 is A3. Was it like integral from A to B f of x dx, same to A1 minus A2 plus A3. Above x-axis positive area, below x-axis negative area, that we call net area. This is like idea. So here, f of x equals 2x squared plus 1 from 0 to 2 is given. Find the Riemann sum with the four subintervals using first one, right-hand point, B, left-hand point. Would you like a Riemann sum with the four subintervals? So here, would you like a Riemann sum with the four subinterval using right-hand point? Here, the first one is the summation I equaled 1 to 4. So for subinterval, we have f of xi times delta x. So same to f of x1 plus f of x2 plus f of x3 plus f of x4 times delta x is the first problem. The second one, the B, summation I equaled 1 to 4 with 4 subintervals, f of xi minus 1 times delta x. We have f of plug 1 into I, 1 minus 1 is x0. Next one is f of x1. Next one, f of x2. The last one, f of x3 times delta x. So let me see. How can we find the like delta x and the xi? We can use the definition here. What's like delta x here? The delta x is exactly b minus a over n. What's b, what's a here? The a is this one, b is last one. So number of subinterval is exactly n. So we have 2 minus 0 over 4 is 1 over 2. What is xi? Xi is I, the a plus I times delta x. This is like xi. What's like a? A is 0 plus I times delta x is here, 1 over 2. So we have 1 over 2i is xi. So we have it. So you can find x0, x1, x2, x3, x4. So we have this one. This is x1. This is x0 first, x0, x1, x2, x3, x4. What's like x0, x1, x2, x3, x4? You plug 0 into I. 1 over 2 times 0 is only 0. You plug 1 into here, 1 over 2, 1 is 1 over 2. Plug 2 into I, 1 over 2 times 2 is 1. Plug 3, 1 over 2 times 3 is 3 over 2. You plug 4, 1 over 2 times 4 is only 2. So we have it. The another idea is we have point 0 and 2. You can make first subinterval. Middle one is 1. The middle one is the 1 over 2. The middle one is 3 over 2. So exactly x0, x1, x2, x3, x4. This is another idea for finding xi's. The next to find function value. F of x0, same to f of 0. F of x1, same to f of 1 over 2. F of x2 is f of 1. F of x3, f of 3 over 2. F of x4, f of 2. You calculate. 맞아, f of 0, plug 0 into here. So we have the 2 times 0 square plus 1. We have 1. You plug 1 half, the 2 times 1 over 2 square plus 1 is the 2 times 1 over 4 is 1 over 2. 1 over 2 plus 1 is 3 over 2. You plug 1. 2 times 1 square plus 1 is only 3. You plug 3 over 2 into x. So we have 2 times 3 over 2. Square plus 1. So we have 9 over 4, 9 over 2. 9 over 2 plus 1 is 11 over 2. You plug 2. 2 times 2 square plus 1 is 8 plus 1. 8 plus 1 is 9. So you can find answer of A. How can you find? You can plug the last 4 numbers here, f1 through f4. We have 3 over 2 plus 3 plus 11 over 2 plus 9 times delta x. Delta x is here, 1 over 2. So this is the 3 plus 9 is 12. The 3 over 2 plus 11 over 2. The 3 over 2 plus 11 over 2 is exactly same to 14 over 2, 7. Times 1 over 2. Answer is 19 over 2. So next one. F of x0 something, first 4 numbers. The first 4 numbers, we can add 1 plus the 3 over 2 plus 3 plus 11 over 2 times delta x is 1 over 2. Here, 1 plus 3 is 4. The 3 over 2 plus 11 over 2 is 14 over 2, just 7. Times 1 over 2. Answer is 11 over 2. This is the answer of this equation. This is the whole idea for solving this problem. So like this. Yep, this is my procedure. The same. So like this. The next one. Find an expression for the area under the graph of f of x equals x squared negative 6x. X is between 1 and 4 as a limit by using right-hand point. So I can do that. I can express for the under the area of this kind of things. The exact meaning is we have here the integral from 1 to 4, the f of x dx. We have this one. You can change the limit definition. Limit, the n approaches positive infinity. We have summation I equal to 1 to n, f of the right-hand point. We have xi times delta x. How can you find delta x? So we can use definition. The delta x is e minus a over n. What's B? What is A? Here, the P is 4. A is 1. We have this first one. This is like A. So this is like B. So we have 4 minus 1 over n is 3 over n. This is delta x. What's like xi? Xi is A plus I times delta x. The A is 1 plus I times the delta x is this top one, 3 over n, 3 over n. So we have 1 plus 3 over ni. This is xi. So you can change. Limit n approaches positive infinity, summation I equaled 1 to n. The f of xi is 1 plus 3 over n I times delta x is 3 over n. The same to limit n approaches infinity. What is f of 1 plus 3 over ni? You plug 1 plus 3 over ni into x here, this x. So we have 1 plus 3 over n I square, negative 6 times 1 plus 3 over n I times 3 over n. That's it. So this is the final answer for solving this problem. The next one, express limit n approaching infinity, summation I equals 1 to infinity, the minus 1 plus 5 over ni q plus 2 times minus 1 plus 5 over ni times 5 over n. So what's that? So this is the same to exactly writing the point. Limit n approaches infinity. Summation I equaled 1 to n. F of xi times delta x. You can compare these two things. So what's like delta x? Delta x is, what's delta x? P minus a over n. What's like xi? Xi is the a plus I times delta x. You can compare. This is same to what? Exactly. This one is here, 5 over n. From here, only numerator b minus a equals to 5. So we have this one. So same thing. This is a plus I times the delta x is here, 5 over n. Same to which one? This is xi is exactly constant plus 5ni, constant plus 5ni. So we have minus 1 plus 5 over ni. So what happens? This a is exactly same to minus 1. You can plug this one into here. Solve for b. b minus negative 1 equals to 5. b plus 1 is 5. Subtract 1 from both sides. The p is 4. So we have a and b. So we have it. So this is a, this is b. The next, how can you find f of x? You can compare. This whole f of x is same to this whole thing. This whole f of x. This one. So what does it mean? The f of xi is the minus 1 plus 5 over ni cubed plus 2 times minus 1 plus 5 over ni. So what's like minus 1 plus 5 over ni? Same to xi. Only replace. So we have f of xi is xi to the power 3 plus 2 times xi. But next, replace xi by x. So what happens from here? F of x is same to x cubed plus 2x. So what's the final answer? Final answer is integral from the A to B. A is -1, B is 4. A is -1, B is 4. So f of x is x cubed plus 2x. X cubed plus 2x dx. So that's it. This is the whole idea for solving this problem. The next one, the evaluate the integral from -6 to 6, the square root of 36 minus x squared plus the absolute value of x minus 2 dx. So what's like idea? So you can just split first. You can just split. You can just split this one. This is integral, the -6 to 6. The square root of 36 minus x squared dx plus integral -6 to 6 absolute value of x minus 2 dx. So let me see. So we have a square root of 36 minus x squared. So we cannot find exact integral by using the integration formula or the use substitution, the impossible. We have an absolute value sign, so we can eliminate absolute value sign by using splitting some of the domains and find this is one good idea, but you can spend a long time. The one best way for solving this problem is graph. So first one, this one, y equals the square root of 36 minus x squared. You can just square both sides. Square both sides. Square both sides. What happens? The y squared is 36 minus x squared. You add the x squared to the both sides. So we have x squared plus y squared equals 36. 36 is 6 squared, exactly circle. But what's the graph? Graph is like this one. We have circle, but only half one because original function is y equals square root of 36 minus x squared, only positive one. Y is above x-axis. You have to ignore below one. The radius is 6. Radius is 6. Graph is like this. From -6 and the 6. So we have this area. Is the first one. So what's that? The 1/2 pi r squared. It's like area. So this one is 1/2 times pi times radius 6 squared. The 1/2 times pi times 36, exactly 18 pi. So this is same to what? 18 pi. This one plus. Second one, you can draw a graph y equals absolute value of x minus 2. What's it like a graph? The graph is like this one. We have the 2 is like a vertex going up and down here, going up like this, and here like this. So you need to find the function values at -6 at 6. You can plug the -6 into here. The -6 minus 2 is -8. Take absolute value +8. We have +8. You can plug 6 into x. 6 into x again. 6 minus 2 is 4. We have only 4. Need to find these areas. This area, the 1/2 times the base. Base is 8. The -6 to 2, right? This is like 2 minus -6 is 8. The height is 8. 2 is crossed out for only 32. So this area is 1/2 times base. Base is 6 minus 2 is 4. Height is 4. 2 is crossed out. Only 8. So what's that? The big triangle plus small triangle. The final answer is 18 pi plus 40. This is whole idea for solving this problem. Like this. The next one, we think about the fundamental theorem of calculus part 1. What's that? Assume that function f is continuous on the closed interval ab. So we have one function, capital F of x. Capital F of x is integral from a to x, f of t dt. You can take the derivative. So capital F prime of x is integral from a to x. Little f of t dt prime is exactly f of x. So one example is like this one. Integral the 1 to x, the tangent of t dt is given. Take the derivative. Only plug x into here. Answer is tangent of x. Exactly the fundamental theorem of calculus part 1. We have application. So what is like replace the x by g of x, integral from a to g of x, f of t dt prime is here. Only plug g of x into here, f of g of x times upper limit prime. The bottom one has a function h of x, top one is constant. What's that? Only plug h of x into t, f of h of x times h prime of x, one more. The function in the bottom one, always take what? Negative sign. The minus f of h of x times h prime of x. The integral h of x to g of x, f of t dt prime. So we have this result. Only plug g of x into here, f of g of x times g prime. You can plug h of x into t, f of h of x times h prime of x, always subtract. Top one minus bottom one. This is the whole idea. What's like example? Find the derivative of the function. Capital F of x is integral from 1 to square root of x sine of 5 plus t squared dt. What's like g of x? Integral from tangent of x to 1 sine of 5 plus t squared dt. So what's like capital F prime of x? Only plug square root of x into here. So we have sine of 5 plus square root of x squared times upper limit square root of x prime. So this is same to sine 5 plus the square root of x squared prime is just x times the root x prime is 1 over 2 root x. So final answer is sine of 5 plus x over 2 times root x. It's the whole idea. The second one, g prime of x, same. You can plug tangent x into here. So we have sine of 5 plus tangent of x squared times tangent of x prime. Really be careful. Take what? Negative sign. Take negative, the negative sign. So we have keep negative sine of 5 plus tangent square times tangent prime is secant squared. We have secant square of x. So that's it. This is the whole idea for solving these problems by using fundamental theorem of calculus part 1. The next one, the fundamental theorem of calculus part 2. Assume that the f is continuous on closed interval ab, integral from a to b f of x dx. You have to find antiderivative capital F of x. Only plug upper limit, lower limit, capital F of b minus capital F of a. where capital F is any antiderivative of little f. What does it mean? Capital F prime is little f. So you need to know indefinite integral. The indefinite integral is exactly the most general antiderivative. So integral kf of x dx is k times integral f of x dx. Integral f of x plus g of x only distribute integral. So we have integral fx dx plus integral of g of x dx. Integral k dx is kx plus c. Integral x to the n dx is 1 over n plus 1 times x to the n plus 1, n is not equal to minus 1. Integral sine x is negative cosine x plus c. Integral cosine x dx is the sine x plus c. Integral secant square of x dx is tangent of x plus c. Integral cosecant square of x is negative cotangent x plus c. Integral secant x tan x is secant x plus c. Integral cosecant x cotangent x dx is negative cosecant x plus c. So we have these rules. Do you know U substitution? U equals inner function g of x, the differential form du equals g prime of x dx. How can you solve integral f of g of x times g prime of x? Only plug u into here. We have integral f of u. G prime of x dx is only du. So plug into here. We have du. Find antiderivative plus c. Change back. The u is g of x. So that's it. That's the whole idea. So here, similar. Only difference is this one. Integral, same. G of x is u. You plug u. G prime of x dx is here. We have du. You have to change lower limit, upper limit by using this relation. You plug a into here, g of a. The u value is g of a. You plug b into x, g of b. Find antiderivative from g of a to g of b. So don't change back u to x value. Don't change back. Only plug g of b into u. F of g of b minus f of g of a. So that's it. That's the whole idea for solving integration problem by using U substitution. So this is some examples. 9 examples. How can you solve these 9 examples? So you can solve each one. The first one, integral 1 to 9, the square root of 5x dx. What's the best way in this problem? Here, only split square root form is better. Integral 1 to 9, square root of 5, square root of x dx. You can change it. The next integral 1 to 9, square root of 5, x to the 1/2 dx. You can keep root 5, find antiderivative of x to 1/2, 1 over 2 plus 1, x to the 1 over 2 plus 1 from 1 to 9. The same to root 5 times 2/3, x to the 3 over 2 from 1 to 9. So this one is exactly same to 2 over root 5 over 3. Only plug 9 into x, upper limit has 9 to the 3 over 2 minus 1 to 3 over 2. And simplify. 2 over root 5 over 3 times. What is it like 9 to the 3 over 2? 9 is 3 square. To the 3 over 2. 2 is crossed out, 3 cube. The 3 cube is 27. So we have 27 minus 1 to the 3 over 2 is just 1. Answer is 2 root 5 over 3 times 26. The 2 times 26 is 52. Root 5 over 3. So this is whole idea for solving first problem. The second problem, we have the product of two functions. What is like the best way? You can change the root form to the exponential form. This is 1 to 4, x to the 1 over 2. This is x plus, we can change it. 2 of x is 2 times x to the minus 1 dx. Next, distribute x to the 1/2. So we have integral from 1 to 4. This power is 1. 1 over 2 plus 1 is x to the 3 over 2 plus 2. 1 over 2 minus 1 is x to the minus 1 over 2. You need to find antiderivative. 1 over 3 over 2 plus 1, x to the 3 over 2 plus 1 plus 2 times 1 over negative 1/2 plus 1, x to the negative 1/2 plus 1 from 1 to 4. So simplify. 2 over 5, x to the 5 over 2 plus 2 times here. The 1 over 1 over 2 is only 2. 2 to the x to the 1/2. You can plug 1 and 4. So what happens here? The 2 over 5 is the 4 to the 5 over 2 plus 4 times 4 to the 1/2 minus the 2 over 5 times 1 to the 5 over 2 plus 4 times 1 to the 1 over 2. This is 2 over 5 times the 4 to the 5 over 2. What's 4 to the 5 over 2? The 4 is 2 square to the 5 over 2. 2 is crossed out, 2 to the 5. 2 to the 5 is 32. We have 32 plus the 4 to the 1/2 is square root of 4. The square root of 4 is 2. 2 times 4 is 8. Minus 2 over 5 minus 4. And simplify. This is 64, I think. 64 over 5 minus 2 over 5. 8 minus 4 is plus 4. So we have 62 over 5 plus. The 4 is the same to 20 over 5. Final answer is 82 over 5. This is the final answer for solving this problem. Like this. See, the integral 0 to 3 pi sine x was like, how can you solve this problem? So one more. You can eliminate the absolute value sign is better. You can just sketch the graph y equals sine x first. The y equals sine of x. You can sketch the graph. What's it like a graph? Graph is like this. Graph is up, down, up, from 0, pi, 2 pi, and 3 pi. This is sine of x. What is y equals absolute value of sine of x? Here, the positive one, same. The negative one, going up. Positive one, same. The next one, this is pi, 2 pi, 3 pi. You can cut. This is same to what? Pi over 2 here. So this area is same to this area. Same to this area, same to this area, is the same and same. How many? 1, 2, 3, 4, 5, 6. You can change it 6 times integral. One more. So this part is exactly same to only sine of x without absolute value. Same to here. This is pi over 2. So, from 0 to pi over 2, only sine of x. This is like idea. We have 6. The integral sine of x is the negative cosine of x from 0 to pi over 2. You can solve 6 times negative cosine of pi over 2 minus negative cosine of 0. The cosine pi over 2 is 0. Here 6 times the change positive, negative is positive, cosine of 0. The cosine of 0 is 1. The 6 times 1 is only 6. We have this answer by using graph. The next one, integral cotangent square of x dx. Let me see. We don't have a formula. We don't have a formula. What's the best way? You can use identity. You need to know this identity is better. We have this one. Sine square of x plus cosine square of x is 1. 1 plus tan square equals secant square of x. The 1 plus cotangent square of x equals cosecant square of x. You need to know these kind of things. What's the cotangent square of x? You subtract 1 from both sides, same to integral. The cosecant square of x minus 1 dx. Integral cosecant square is negative cotangent. The integral one is just x. We have this answer. It's the whole idea for solving this problem, the D. The next, the integral from pi over 6 to pi over 2 cosine x over sine cube x dx was the best way. In this case, you can use U substitution. Was it like U? The U is usually, what's U? Usually inner function sine, because the sine prime of x is cosine. This is the reason. The derivative is in the integrand. This is like a good choice. U equals sine of x. The du is sine x prime cosine x dx. You can change integral. This is like g of x form. Bottom one is g of pi over 6, g of pi over 2. The cosine x dx is exactly du. Change 1 over like a du form. Sine x is u cube. Same to integral. The u to the negative 3 du form. You can find g of pi over 6. What is g of pi over 6? G of pi over 6 is, plug pi over 6 into here, sine of pi over 6. Sine of pi over 6 is 1 over 2. We have 1 over 2. You can plug pi over 2 into g of pi over 2. You can plug pi over 2 into this x, sine of pi over 2. Sine of pi over 2 is just 1. The next, find antiderivative. 1 over the negative 3 plus 1, u to the negative 3 plus 1 from 1/2 to the 1. This is the 1 over minus 2 is negative 1 over 2, u to the negative 2 from 1 over 2 to the 1. Change to the positive exponent, negative 1 over 2 times u squared from 1 over 2 to the 1. You can keep minus 1, plug 1, 2 times 1 squared, minus negative 1 over 2 times 1 over 2 squared. This is negative 1 over 2. Change positive. This one is same to 1 over 2 times 1 over 4. This is minus 1 over 2. 2 is crossed out, only 2 plus 1 over 1 over 2. You can flip. Minus 1 over 2. 1 over 1 over 2 is only 2. So minus 1 over 2 plus 2 is 3 over 2. This is the final answer of this question. So like this. So here, how can you solve integral 1 over 2x plus cube to 5? So similar. You can use u substitution. U equals the 2x plus 5 like inner function, this one. The du is the 2x plus 5 prime. 2x plus 5 prime is only 2 times dx. And the next divided by 2 because integrand doesn't have 2. So this is 1 over 2 du equals dx. So what's that? Integral 1 over 2x plus 3 is u. The dx is here, 1 over 2 du. So take out 1 over 2. Integral 1 over u to the 5 is integral u to the minus 5 du. So 1 over 2 times, you can use power rule. 5 plus 1, u to the minus 5 plus 1 plus c. This is 1 over 2 times negative 1 over 4 times u to the minus 4 plus c. You can combine. 1 over 2 times minus 1 over 4 is negative 1 over 8 times u to the minus 4 is 1 over u to the power 4 plus c. So minus 1 times 1 is negative 1 over 8 times. You can change it back. What's it like u? The u is here, 2x plus 5. 2x plus 5 to the power 4 plus c. So that's it. This is whole idea for solving the number f. The next one, integral, what's the difference? So this one doesn't have x in the numerator, but this have x. So we use same idea. What's it like u? The u is 2x plus 5. The du is same. The 2x plus 5 prime, the 22, 2 times dx. So this is same to integral. What's like bottom one? U to the 5. So dx is 2 times du. Same. How can you deal with x? You can use this relation. You can subtract 5 from both sides. Subtract 5 from both sides. The 2x equals u minus 5 divided by 2. X is 1 over 2 u minus 5. So keep 1 over 2 u minus 5. So 2 is crossed out. It's the same to integral u minus 5 over u to the power 5 du. You can just split u over u to the 5 minus 5 over u to the 5. Use crossed out only 1 over u to the 4. Change it to the negative exponent. The u to the negative 4. The minus 5 times same u to the minus 5 du. You need to find antiderivative by using power rule. 1 over the minus 4 plus 1 u to the minus 4 plus 1. Minus 5 times 1 over minus 5 plus 1 u to the minus 5 plus 1 plus c. Same to 1 over negative 3, 1 over negative 3 u to the negative 3 the minus 5 times the 1 over negative 4 u to the minus 4 plus c. You can change. This one is keep negative 1 over 3 times u cube. Change it like this. This one is change it positive 5 over 4 times u to the 4 plus c. You can change it back. Was it like u? So u is here. 2x plus 5. Change it back. Negative 1 over 3 times 2x plus 3. Oh, sorry. Not 5. This is my typo thing. 3. Sorry about that. 3. 3. This is what? 3. 3. You can change it 5 by 3. 3. 3. 3. 3. And 3. Only 3. 2x plus 3 cube plus 3 over 4 times 2x plus 3 to the power 4 plus c. Okay, this is like a whole idea for solving this problem. Like this. Oh, what's 16? Why do you have a 16? My typo? Oh, wait a minute. What's that? I don't think so. Why do you have a typo? Oh, 5. Yep. Oh, where's your 104? Oh, I see. This is my typo. Sorry about that. Here. Oh, here. I didn't divide by 2. Divided by 2. So what's that? This is 1 over 2 du equals dx. So you can change it. It's 1 over 2. Sorry about that. So 1 over 2 times 1 over 2 is take out 1 over 4. Take out 1 over 4. Take out 1 over 4. Whole thing times 1 over 4. This whole thing times 1 over 4. Whole thing times 1 over 4. So this is 12. 4 times 4 is 16. So sorry. This is like whole idea. So really be careful for solving this problem like this. Yep. We have it like this. Next tip. How can you solve this problem? You can use the u substitution again. Was it like a u? U is inner function square root of x. Was it like a du? Du is the square root of x prime dx. So we have du equals the square root of x prime is 1 over 2 root x dx. The multiply by 2, the 2 du equals 1 over root x dx. So we have it. You can change it. It's the same to 1 over cosine square of root x times this one, 1 over root x dx form. 1 over root x dx form. So what's that? Integral 1 over. The square root of x is u. You can plug. Cosine square of u. The 1 over root x dx is here, 2 times d. So this is same to the take out 2 integral. What's 1 over cosine square of u is exactly secant square of u. This one. Next to 2 times. Integral secant square is tangent of u. So we can just change back. The u value is here. Square root of x. 2 times tangent of square root of x plus c. So that's it. This is your final answer for solving this problem. The next one. How can you find the answer of this question? the similar. You have to use U substitution. U equals this one, 1 plus tangent x, because 1 plus tangent x prime is exactly secant square. We have 1 plus tan x. The du is the 1 prime 0, tangent prime is secant square. This is the same thing, right? G of x. 이내가 G of 0. You plug pi over 4 into x, G of pi over 4. The 1 plus tangent x is u. We have u to the 4. Secant square x dx is du. You can find G of 0. What is like G of 0? G of 0 is plug 0 into here, 1 plus tangent of 0. Just 1. What is G of pi over 4? You can plug pi over 4 into x, 1 plus tangent of pi over 4. 1 plus tangent of pi over 4. This is tangent of pi over 4 is 1. 1 plus 1 is 2. Can change 2. U to the 4 du. It's the same to find antiderivative u to the 5 over 5 from 1 to 2. Can plug 2 to the 5 over 5 minus 1 to the 5 over 5. 2 to the 5 is 32 over 5 minus 1 over 5. Final answer is 31 over 5. This is the whole idea for solving this problem. Like this. The last one, the integrals of symmetric functions. Suppose f is continuous on closed interval negative a and a. If f is even function, the integral negative a to a f of x dx is 2 times integral from 0 to a f of x dx. If function f is odd function, f of minus x is minus f of x, then integral from negative a to a f of x dx equal to 0. Why? I can show to you. This is even function. The even function is always symmetric about y-axis. This whole area is exactly same to the 2 times only right hand side, right? Exactly. This area is same to this area, the 2 times only right hand side. Odd function. Odd function is always symmetric about the origin. So this area is the same to this area. So below x-axis, negative area. Above x-axis, positive area. So always the minus a plus a is 0. Always 0. So let me see. This is like true or not. How can you know that? You can check f of minus x. Here, this is f of x. This is f of x. You plug minus x into x. So we have sine of minus x over 1 plus negative x squared. What is sine function? The sine function is odd function because sine function is graph is like this. Always symmetric about the origin. Symmetric about the origin, what does it mean? Odd function. So we have negative sine of x over 1 plus 2 is even power, minus x squared is just x squared. Same to negative sine of x over 1 plus x squared. Only replace sine x over 1 plus x squared by f of x minus f of x. So what's that? Function f is odd function. Function f is odd function because minus f of x is negative f of x. So answer is yes, 0. This is like the whole idea for solving this problem. Like this. Okay, this is all for today's lecture. I hope that this review session is very helpful for preparing your final exam. Thank you for watching my lecture video.